This is the first video to get you ready for the Chapter 6 test, which is over differential equations. So this video is going to start with the very beginning of the chapter, which was a lot of verifying or determining if things were solution, and then an integration review. And then we'll move to the idea of separating and integrating to find general solutions. So the first thing that you see here, the first question, wants to determine if the function y equals 2 sine 2x is a solution to the differential equation. So when you see the word determine, the first thing that you should realize is it may work, it may not work. This is not a situation where it says verify and you know for sure it's going to be true. So this is a yes or no type question. The second thing you want to look and see is how many derivatives do you need to take in order to start making those replacements to check. And if you look at your differential equation, this is a third order differential equation because it has a third derivative. So I like to go off to the side and start listing my derivatives up until the one that I need to know. So the derivative of sine is cosine, but you also have to derive the derivative of the angle. So you're going to be multiplying by 2. That gives you 4 cosine 2x. Then we're going to derive again. The derivative of cosine is negative sine. I'm going to multiply by 2 again. So every time I'm going to have to multiply by the derivative of the angle. So I get negative 8 sine 2x. And then one more will get me to my third derivative. Derivative of sine is cosine. It's going to stay negative, and I'm going to multiply by 2 again. So I get negative 16 cosine 2x. So there is as far as I need to go with my derivative process. Now I want to do my replacements. The goal is that you replace every derivative and every original y with the derivatives that you've found and see if the two sides are equal. So if I plug in a negative 16 cosine 2x for the y triple prime minus 8 times the original y is right here, 2 sine 2x, I want to see if that indeed will equal 0. And what you'll notice here is it will not. A couple issues, obviously. They're both negative, so they're not going to cancel. And we actually have two different trig functions. We have a cosine minus a sine, and that's not going to cancel. So my answer to this one would be no, it is not a solution. And my reason, my justification, is the work that you've shown. So you don't have to do any extra work. You don't have to write a sentence explaining it. Your work stands for your explanation. The next thing that we did in the beginning of the chapter was we started just reviewing basic integration because that's really what a differential equation is. It's a way to integrate and get a general solution. And so we're starting with these two that you see here that are not a separate and integrate. They are just the derivative in terms of x's. But I tried to pick some harder ones to just make sure you remember how to do some of the more complicated ones. So for this one, your u is going to be the cosine of 4x, because that is the piece that's having something done to it. The derivative of cosine 4x is negative 4 sine 4x. So we're going to have to divide by negative 4. So my adjustment is negative 1/4. It is a u to the third du. It is a power rule because it's being taken to the third power. So I get u to the 4th over 4 times by the adjustment, the negative 4th. My final answer is going to be negative 1/16 when I multiply the 4 times the 4, and then cosine to the 4th of 4x plus c. I chose this one because there's a lot of little mistakes students can make. It's easy to forget the negative sign. It's easy to forget the adjustment, to forget to put the 4x back in, and make sure you don't say that it's just the cosine of x. That angle can't change. The next one actually is similar to one that you would have done on your midterm. It is a u-sub, but the difference between this one and some of your regular new u-sub problems is this ends up being a complete u-sub, so this takes a little more work. So my u is x minus 7. The derivative of that is just dx, so it has no adjustment. But I have this extra variable here, and that is what I'm going to have to replace with whatever x is. So I'm going to take this equation right here, and I'm going to solve it for x. So x is u plus 7. So when I write my integral in terms of u's, I have a 2. That's just from the original integration form that I want to use. The x is u plus 7, and the radical would be u to the 1/2. Now, if you want, you could actually bring this 2 up front. It's not going to do anything. It's a coefficient, but you definitely need to take the time to distribute here before you try to integrate. So when I distribute and I add powers, I get u to the 3/2 plus u to the 7, 7u to the 1/2. Integrate by doing your power rule. It's going to be power 1 greater divided by that power. So you're going to get 2/5 u to the 5/2 plus 7 times 2/3 u to the 3/2. you still have this 2 out front, and you can choose whether you want to keep it out front or distribute it through. It does not matter to me. A lot of times students don't like to mess with the distributing because you don't want to accidentally make a mistake. So I'm just going to leave the 2 out front, but the one thing I am going to do is I got to put what u is back in. So u was x minus 7, so I'm going to have an x minus 7 to the 5/2 power plus 7 times 2/3 is 14/3 times x minus 7 to the 3/2 power plus c. If it was a multiple choice test, the only change in what you might see is you might see that 2 distributed. So you may see it as a 4/5 instead of a 2/5, and you may see it as a 28/3 instead of a 14/3. Other than that, you're not going to see extra pieces done as far as simplifying on a multiple choice test. Now we're going to switch a little bit to ones that we can't integrate immediately. We have ones where we talked about how your x's and y's are kind of jumbled up. When you see dy dx, if it's easy, what that means is everything is in terms of x, and that's not what you have with this one. So we have to do a little maneuvering to get it in the correct form to integrate. I'm going to divide this side by y, and I'm going to multiply this side by dx. So I get dy over y equals 3x squared dx. The goal in separating is to make sure all of your y's end up on one side with the dy. dy stands for the variable of integration that were in terms of y. And all your x's on the other side with your dx. And the dx can't be part of the denominator. It has to be multiplied. Once you do that, you're ready to integrate because you have everything in a correct form. So the integral of dy over y is the natural log of y. The integral of 3x squared is x cubed. And I do need a plus c. You should get in the habit of putting it at the end. We talked in class that you'll never see your answer left this way. You are always going to see it exponentiated, so that will get rid of the natural log. The other thing that you're going to see, and we did this in class with exponent rules, is that this is the same as e to the x cubed times e to the c, and e to the c is just a fancy way of saying another constant. So you end up with c e to the x cubed. We actually did this exact one in class. The difference is this one takes it one step further because it wants you to find the particular solution. And what you'll see with that is they'll actually use the wording, find the particular solution. Sometimes you'll just have a point there indicating that you need to go further. And a lot of times with a multiple choice, you'll look at your choices and you can eliminate some. For example, if it's not in this form where you have the e to the x cubed and you have some constant in front of it, it's not the right answer. But to go that one step further and find c, I need to plug 0 in for x and 2 in for y, so 2 equals c e to the 0 power. E to the 0 power is 1, so that means c is 2. So my final answer, my particular solution, is 2 e to the x cubed. Once you find that c value, please put it back in so you have that particular solution that no longer has a constant, a generic constant in it. And then finally, the last one that I want to do on this video came from a AP prep book. So just getting an idea, I wanted you to see what a multiple choice question could look like. So I did kind of a cut and paste so you could see what would be given. And then I also put what the choices were. So you not only can figure out the right answer, but you can kind of get an idea of maybe some of the wrong answers that might be there and hopefully not fall into any traps. So when you look at the directions, you have that the derivative equals this particular function, and it tells you when y is 4, x is 2, and it wants to know when x is 3, what is y. Some of the times the trickiest part of this particular problem is it doesn't tell you to separate and integrate. It really doesn't tell you anything at all other than here's some given information. On this particular test, that's going to be easy because the whole chapter is all about separating and integrating. But when you're taking an AP test and it's mixed in with a whole bunch of other questions, you might not right off the bat realize what has to happen. So first thing I want to do is figure out the best way to separate this. This one is pretty easy. You can just cross multiply to separate your variables. So you get y dy equals 3x squared plus 2 dx. It's also very easy to integrate. This is one of the few times you actually don't have a natural log in this one. You get y squared over 2 equals x cubed plus 2x plus c. Here's where you have a choice. If you want to take some time to simplify it, if you want to solve for y, you can. If not, you can immediately start plugging in the x and y and find c. There is nothing that says you have to simplify. Whenever you get going a little further and you find c, you'll have to do a little simplifying to get the final answer, but it doesn't have to be done now. So I'm just going to start plugging in my x and my y. I know that y is 4 when x is 2. So if I put 4 in here, 4 squared is 16, divided by 2 is 8. If I put 2 in here, 2 cubed is 8. Plus 2 times 2 is 4, plus c. I end up getting, when I subtract 4 from both sides, I get c to be negative 4. So my particular solution is y squared over 2 equals x cubed plus 2x minus 4. If all they wanted was a particular solution, you would be done. This one wants to go a step further and actually use this particular solution to answer an additional question, which is what happens when I put 3 in for x? What do I get for y? So that's what you want to do next. You want to put 3 everywhere you see an x. So we have y squared over 2 equals x cubed, so 3 cubed, which is 27, plus 2 times 3, which is 6, minus 4. So we get 27 plus 6 minus 4 is 29. And here's where the simplifying is going to happen. Since you didn't simplify before and get y by itself, now you need to get y by itself. But really, once you put numbers in, it's not that bad. We're going to multiply by 2. So we get y squared equals 58. Take the square root of both sides. You get y equals plus or minus the square root of 58. Look at your choices to see which one it is. And if you look at your choices, you get the only one that is there is the positive square root of 58. If they were both there, and then rarely do you see that, but there are some certain situations, especially on FRQs, if you have both options and you want to know which one do they want, look at your initial condition. Look at the fact that when you plug 2 in, you got a positive y value, not a negative y value. If you actually went and looked at your particular solution here, if you looked right here and plugged in 2, what you'll see is when you got a positive answer, so that means it must have went one of the positive square root, which is why you have the square root of 58 here. Now the nice thing about this problem is the negative wasn't even a choice. But if it is, you can use your initial condition to figure out, was I looking for a positive answer for y or a negative answer for y based on that initial condition. This one has a positive y, so I was looking for the positive square root. This one's a little more challenging. Again, this was straight from an AP prep book, so you get to see a better idea as far as how it's worded and what your choices are. You can see, looking at the wrong answers, what would happen if you didn't take the square root and obviously got letter C, or what would happen if you did some of your arithmetic wrong. You're going to end up with either B or D. So hopefully this is a good first introduction to getting ready for the Chapter 6 test.